Lesson 15.3 deals with fitting a polynomial function to data. It says the graphs below show 4 cubic functions that could model the position of a moving object as a function of time. So this object passes the reference point. That's basically the x-axis, and then slows down. You can tell it's slowing down based off of the slope of the function, that the curve actually doesn't rise as fast as it used to. And then it speeds back up, meaning that, again, the slope has increased. So passes the reference point, slows down, speeds back up. This one passes the reference point, momentarily stops. That's when its slope is 0, but then continues forward. Here you have one that passes a reference point, reverses direction, so now it's coming back towards the reference point, reverses direction again, and speeds away. And in this one, it approaches it from the opposite direction, momentarily stops, and then passes the reference point. In all 4 cases, there is only one x-intercept if we look at the graphs, one time where it crosses the x-axis, which would give us 1, 0. But we can clearly see that these functions are not linear, which would have 1 factor, 1, 0. In fact, they're cubic, so they should have a total of 3 zeros. This one's clearly cubic and not linear, okay? So it should have 3 zeros, which means 2 of them are hidden somewhere. 2 of them are irrational. Now, you recall the constant second difference property for quadratic functions says for a cubic function, the third difference between the y values are constant. And it actually is a constant nth difference property that says for an nth degree polynomial function, if the x values are equally spaced, then the f of x or y values will have a constant n difference. So a function to the 4th power will have a constant 4th difference. Something to the 10th power would have a constant 10th difference. A cubic has a constant 3rd difference. We already talked about quadratic, have a constant 2nd difference, and on and on and on.